morning from Copenhagen and welcome to the webinar on evolution of district cooling in the GCC region, hosted by the Copenhagen Center on Energy Efficiency. My name is Trupti Yargattimath and I'll be providing the technical support for today's session. Before we begin, I'd just like to mention a few points about the webinar as well as the Copenhagen Center. The webinar is scheduled to be 90 minutes long with time for question and answers towards the end. So please use the dedicated icon to send us your questions and we will do our best to answer as many as possible towards the end. Finally, a few words about the Copenhagen Center. We are a research and advisory institution who are dedicated to accelerating the uptake of energy efficiency policies, programs, and actions globally. We also serve as the Sustainable Energy for All Initiatives Energy Efficiency Hub. We also host webinars on energy efficiency related topics, and you can find all of the previous recordings on our website's knowledge management system, including all the presentations. This webinar will also be recorded and made available on our website system in a few days. And now, without further ado, I'd like to welcome Mr. Sayeed Mohammed, who will be moderating today's session. Sayeed is a visiting scholar and the assistant professor at Georgetown University in Qatar. So Sayeed, the floor is all yours.
Thank you, Trupti. Thank you, everyone. And thanks a lot for taking time to join the program. I really appreciate for taking time to from your busy schedule. And today is an important session to understand about district cooling. And in the last 20 years, many of the Gulf cities have made significant strides in reducing kind of emissions through different means. And one such possible mean is district cooling. And today we wanted to know how district cooling has evolved over the last 20 years and what kind of challenges that each of the providers, regulators have faced and how they managed to overcome it and how they managed to keep the target of providing best services to the community at the same time, keeping the environmental goals in sight and also make district cooling a more profitable venture. And today we will hear from three experts, and two of them are district service providers and one a regulator from Qatar. So I will not going to give the whole definition of district cooling, which you're all aware. So we're going to dive in directly. I'm going to ask Qatar Cool representative, Ms. Aysha Al-Shriem, and she's the chief officer and sustainable lead to speak about Qatar Cool. And after that, we will have other speakers follow up. Ms. Aysha, you have 20 minutes for presentation. Please go ahead.
Good morning, all. Apologies, I joined through two devices, so sorry if I'm not looking directly at the camera all the time. So just want to say that I'm delighted to be here today as a panelist, and I would like to express my gratitude for the opportunity to contribute to this important discussion. The rising cooling demand in GCC region presents a significant challenge for energy planners. Not only does contribute to higher natural gas consumption and power generation, but it also impacts the prospects for exports. However, in the middle of all these changes, there is a growing recognition of district cooling as a promising alternative to conventional cooling methods. I have the privilege of sharing our expertise here today and insight on this critical topic. So we shall make a start. I'll start by talking a little bit about Qatar Cool. Who is Qatar Cool? What do we do? Qatar Cool is the largest district cooling provider in Qatar, with more than 30,000 corporate and private customers. We own 60% market share of Qatar district cooling with a cooling capacity of 4.2 billion ton refrigerant hour, produced by 5 plants to serve more than 500 buildings. Some environmental highlights. Our electricity savings to date is 3.3 billion kilowatt hour. CO2 avoided to date is 1.8 million tons. Potable water savings since 2015 is more than 6 million cubic meter. Utilized more than 1 million cubic meters TSE in cooling plants, and also reduction in natural gas of about 34 million MMBTU. What is the difference between conventional cooling and district cooling? District cooling means cooling multiple buildings in a local area or a district. So as the name dictates, district cooling. On the left, you can see conventional cooling technology, So these are the cooling methods that are used. At present, district cooling is one of three main systems used for air conditioning in the region. The most localized of them is conventional window units or split systems. These provide air conditioning at the level of a single room, an apartment, or a small building. Large buildings use another system, central air or water-cooled chillers. These tend to be placed on the building's roof or even in the basement. And the least localized system is district cooling. I'll talk briefly about how district cooling operates. In the district cooling plant, water is chilled and then supplied to customer buildings through the network of pipes. The chilled water is then fed into the building's own cooling system through the heat exchanger, which we call ETS, and then fed back to the cooling plant in a closed loop where it is chilled again and redistributed. Why choose district cooling? District cooling offers significant advantages in cost, environment protection, comfort, and operational efficiency over other cooling technologies when used in sufficiently dense areas. As you can see here on the slide, up to 50% reduction of energy consumption, more than 50% reduction in CO2 emissions and other hazardous gases. It also frees up space, which could be utilized for other aesthetic purposes, like, for example, installing swimming pools or gardens instead. Why district cooling is important during conceptual design? Well, because of many reasons. One of the reasons is the space allocation. It is very important that plot gets allocated for the plant and for the pipe distribution network, and also other utility requirements. Another reason, it could be greater utilization and a reduction of electrical demand. Another reason would be cost optimization. It is very important that you plan ahead of time to include district cooling in your financial model and to allocate the charges properly. And I can't see the right side. Promote the project ESG-wise. The project will sell most probably more if you promote it as an environmentally friendly project. This slide is about the services we provide on Qatar Cool from A to Z. It starts with design and ends with customer service support. Design, procure and build operations, and maintenance all happen in-house. We have a good relationship with key suppliers. We have state-of-the-art command and control center to remotely monitor and control our plants, metering and billing systems, full deployment of smart meters, and we control the entire building cycle in-house as well. And we have customer support center and call center for handling customer service requests with multiple payment channels. International expansion key region. Balance sheet flexibility, access to capital, and regional know-how make Qatar Cool well positioned for regional expansion in nearby markets. Well-being in the Gulf region depends on air conditioning. Summer temperatures in GCC countries frequently exceeds 45 degrees Celsius with high relative humidity. Air conditioning in the GCC is an expensive necessity, and between now and 2030, cooling demand in GCC is expected to nearly triple. So district cooling could provide around 30% of GCC's forecast cooling needs by 2030. This would prevent the region from having to build new power generation plants and will also save a lot of fuel. As you can see here on this slide, growth is notably expected to materialize further in the region, particularly in KSA and Qatar and other MENA countries such as Egypt. The consistent use of district cooling offers quantifiable advantages and qualitative benefits over current use patterns. District cooling is the answer to climate change, population growth and urbanization, and growing economy. Higher return How? By having higher return on investment. This lowers investment cost and operating cost, and it lowers deterioration of equipment with longer life cycle. It's best suited for regional master development. It lowers CO2 and other pollutant emissions, and reduces power consumption and electricity, and reduces overall tariffs as well, and in addition to easy maintenance. In the context of our webinar on the evolution of district cooling in GCC, the Sustainable Development Goals serve as a compass guiding us towards sustainable development and environmental stewardship. Both Qatar and Qatar Cool have a strong commitment to adopting and implementing the Sustainable Development Goals in addressing global challenges and shaping the future we want in line with Qatar Vision 2030. These are some of the environmental achievements and initiatives. I'm not going to go through all of them, but I will mention a few as an example. In terms of water, TSC usage in operations in West Bay last year was 94.4%. Water recovery last year in P3 was 70%. And then we have more water saving last year versus 2015 of 81.7%. This is through increased TSC usage. Currently, we're operating 2 reverse osmosis plants on site. In addition, we use thermal energy storage in plants to reduce peak time pressure on Qatar's power grid by producing chilled water during off-peak power hours. Use of artificial intelligence to manage thermal energy storage to reduce energy consumption. Okay, there's an issue with can't just minimize this. Sayeed? Okay, good.
Yes. Yeah. You need anything? Yeah.
No, that's okay. Okay, good. So we'll move to efficiency in both energy and water. Qatar Cool has been consistently overreaching the company's target in terms of electricity usage. Last year only, the operation efficiency was 13% higher compared to the design benchmark. Qatar Cool continues to integrate additional water conservation into operations, and the current water efficiency KPIs indicate an optimal level of water efficiency with reverse osmosis treatment contributing to lowering the water consumption. This slide is self-explanatory. It shows energy reduction and CO2 reduction over the past 10 years in millions. So on the left is energy saving, on the right is CO2 reduction. This slide shows utilization of potable water and the utilization of TSE. Less and less potable water over the years. On the other hand, more utilization of TSE. The use of TSE in operations leads to cost saving and more sustainable operational service. Advantages, significant reduction in capital and operational cost, environmentally friendly solutions reducing the demand for fresh domestic water, and TSE water is 34 times cheaper than the cost of fresh domestic water in Qatar. At the bottom, you can see the evolution of using TSE water at Qatar Cool over the years. Examples of how we manage natural resources and water ecosystem. Reverse osmosis per plant's RO, it uses seawater, whereas West Bay plant's RO uses TSE. For instance, the use of thermal storage energy, the TES tanks allow the storage of cold energy for peak periods and allowing significant energy saving. Another example is cycle of concentrate, or what we call it COC. We saved over 400 million cubic meter of water. We introduced new chemicals to treat the water, which increases COC. And finally, we are using irrigation features, low flow fixtures, and TSE as an example of water efficiency. Innovation and technology play a crucial role in driving sustainable operations in our plants. We understand that embracing advancement in technology and harnessing innovative solutions are key to achieving our sustainability goals. Here are a few ways in which we deeply integrate innovation and technology into our plant operations. For example, the artificial intelligence, we have several ongoing projects that look at bringing in AI into our operations and our office functions. One such project is using AI to enhance our efficiency by improving delta T. This is achieved by using AI to improve the return water temperature from the ETS. Another example for innovation technology is optimization. Energy transfer station optimization research and testing was concluded successfully last year. It is now being rolled out. Another example is the waste management. We have a circular mindset when it comes to waste. For example, refrigerant recycling, repurposing of assets, repurposing of brine, CO2 capturing and offsetting, and TSE utilization. And another example is GHG and pollutions. So district cooling by design reduces greenhouse gas and pollution. In addition, this made Qatar Cool such a green company. We're adding some vertical gardens in the newest cooling plant that we have built here in the Pearl. And also our plant 3, or what we call it P3 in the West Bay, is a LEED certified plant. With this slide, we will shift our focus to the critical issue of global greenhouse gas emission. It is crucial to understand that the broader context of GHG emissions to drive impactful change on a global scale. GCC region is a significant contributor to GHG emissions, particularly due to the refrigeration gas emissions resulting from air conditioning system. Rise in emissions means increase in populace. A warmer climate increases the demand for cooling, and unfortunately often from unsustainable quick fix, usually conventional cooling. A warmer climate increases the risk of heat-related illnesses and deaths. A warmer climate increases certain types of air pollution and more severe heat waves, floods, and droughts. And this also, unfortunately, leads to reduction in crops. It is worth mentioning that greenhouse gases is not only CO2, but there are also other gases there. However, the majority is CO2, which constitutes 76%, followed by methane, 16%, followed by nitrous oxide, 6%, and then synthetic chemicals, 2%. On the left side, you can see the global warming potential. So if carbon dioxide participates once in this, methane participates 25 times, and nitrous oxide 300 times, and so on and so forth. This is a very important slide that I think we may be having a lot of discussion on. What can others learn from our experience as a district cooling provider? I listed here the major barriers and obstacles to district cooling. For one, non-aggregated development decisions. Developers are not aware of the advantages of collaborating with their neighbor developers to share a district cooling network. Developers should always have an early discussion with their neighbor developers and decide whether or not they would like to go forward and with a district cooling network. Another barrier is cost misperception. Developers usually pass on the cooling cost to end users. This leads to district cooling appearing to be expensive. That is another barrier. Another one is the poor load planning. Poor load planning results from developers to over estimate or underestimate the load required. Another barrier is the non-economic utility pricing. In GCC, we have low electricity tariffs, which actually is considered a barrier, making district cooling look more advantageous only in high-density areas only. Another problem is the risk of early investment. District cooling requires a very big, significant front-loaded investment. Inconsistency of cost recovery model. We do have really inconsistent cost recovery models that are used for different projects. So each project has a different and require a unique approach to recover cost. So these are the barriers that we think or obstacles that hinders countries from going forward and decide whether or not to go with this.
Aysha, you have 2 minutes.
Okay, great. That's actually my last slide. Solutions for governments, particularly on how we can overcome these barriers. Designation of appropriate zones. Government should mandate district cooling in designated areas where district cooling makes sense. So you should designate appropriate zones. Tariff regulation, we should have consistent national tariffs for district cooling and correct allocation of charges. End users should only be paying consumption charges. And the last solution that for government to overcome is to have services standard and technical guidelines. So we have the defined basic levels of reliability and performance standards and setting economic rules. In conclusion, I think the long-term potential capacity and fuel savings alone justify government intervention to prevent this important technology from staying on the sidelines as GCC economies grow over the next 2 decades. That's it. I'm done. Thank you.
Thank you very much, Aysha. Thank you. That was right on time. And if you have any questions, please feel free to drop your questions in the Q&A chat box. We will come back to you after all the 3 presentations are over. Now I will ask Mr. Antonio de Cecca, and he's the Chief Operating Officer of Tabreed. Please go ahead.
All right, thank you. Thank you very much. I hope everyone hears me well. Actually, I have issues with the camera, so you will not see my face, but at least I hope you will see the slides. First of all, thank you for the kind invitation. I'm very honored to be in this webinar. I hope this contribution will help the development of district cooling further in GCC. We heard about our colleagues in Qatar Cool, how important is district cooling for the sustainability of our industry and also for the contribution to the carbon footprint, reduce the carbon footprint of cooling worldwide. As Tabreed, or national cooling company, we are based in Abu Dhabi. It's active. We are present, based in Abu Dhabi, founded 25 years ago, so a quarter of century already gone, with significant contribution in the UAE and GCC in general, in terms of reduction of energy, electricity consumption and CO2 emissions. As of today, Tabreed counts 87 plants established in 4 different countries in GCC, with new developments also recently in Egypt and India. Here you will see our environmental responsible operation in terms of energy consumption savings through Tabreed operation, 2.31 billion kilowatt hour of electricity, equivalent to the consumption of 130,000 homes. This is the impact that we measure, considering district cooling almost 50% more efficient than conventional systems, conventional cooling systems. On top of it, we have the reduction corresponding to the CO2 emissions and the life cycle cost savings, almost 20% in terms of life cycle cost savings. Total capacity delivered to customers almost 1.4 million tons of refrigerant tons. And we are, as I said, present in all GCC countries. In particular, we have B2B business related to our main customers. You can see here, most of them are real estate developers present in UAE and other GCC countries. And we are also the exclusive DC provider of iconic projects like the Sheikh Zayed Mosque in Abu Dhabi, or the Cleveland Clinic in Abu Dhabi, also Dubai Metro, Burj Khalifa, and all Dubai downtown, etc. So, as I said, Tabreed is present in GCC since almost 25 years. We have our operations active in 4 GCC countries as of today, with a uniform utility infrastructure model implemented in all our countries. And we recently entered into operation into 2 new countries, in Egypt, where we have plant already established, district cooling plant already established in New Cairo, and recently also in India, where Tabreed has established a joint venture with IFC from the World Bank to develop district cooling in India and other Asian countries. This will be the platform for development in this region. Our long-term contracts underpinning stability and of earnings and return for our shareholders, but also for our customers. And I would say that this our strategy is to continue growing in GCC and a particular focus on areas where district cooling is not mature yet. Like we said, India, for example, is one of the market with the highest potential for growth and the most challenges in terms of reduction of the environmental footprint of cooling. Why district cooling and cooling in general is today on the top of the agenda of many discussions on energy efficiency, sustainability, etc. And also for COP28 that will be hosted here in UAE in November this year. If we look at the cooling demand in GCC in general, in any of GCC countries, we saw Qatar before, but also UAE is the same. During the summer, the peak electricity demand, when we look at the breakdown of the contribution, 70% is represented by cooling, which explains a lot in terms of efforts that should be done to tackle the problem of peak electricity and network stress and capex on power demand side. So if we consider that this is the contribution of cooling to electricity demand and the fact that there are technologies that are much more efficient than conventional standalone cooling, like district cooling is, which is more than 50% efficient, then we can understand how simple the equation is. Even though this district cooling is still considered a niche market still in GCC and worldwide. I believe worldwide district cooling counts for almost between 1 or 2% of the total cooling. And here in GCC, in particular in UAE, we are between 20% the biggest district cooling. So you can understand that there is a long way to go, but we are very confident because, especially when we look at the Vision 2030 of UAE, there is a big movement towards more energy efficiency, and especially in the the strategy to reduce carbon emission by 30% before end of 2030, and to be net zero by 2050. So the contribution of district cooling will be crucial in this. Here I would like to give you some examples of the impact of district cooling in decarbonizing the electricity grid. We said that district cooling is more efficient compared to conventional cooling solutions, such as air-cooled chillers. We did an exercise and we considered the full area of Abu Dhabi Island, so the oldest part of Abu Dhabi, where unfortunately the penetration of district cooling is very low. And we consider that the increasing demand every year is substantial. Space cooling demand every year increases between 5 and 10%. So we have done a study including different kind of buildings, mixed-use hotels, schools, hospitals, offices, etc., including also residential. And with the simple assumptions on the unit load per building, we arrived to the conclusion that we can reduce the energy consumption by 40% simply implementing district cooling in all this area, with more than 1 billion kilowatt-hour reduction. So passing from the 2.6 billion, that is the consumption that we have as of today, to 1.6 billion, replacing all this cooling system by district cooling. And this also generates also savings in terms of CO2 emissions, 1.1 billion towards 0.7 billion if we implement district cooling. Another example in the next slide, and here we focus more on operational efficiency and operational excellence. District cooling, as we saw before, in our colleagues from Qatar Cool were showing improvement of energy efficiency during the year. So this is the global pattern that we are observing in all the region, with efficiency as low as 0.8 kilowatt of electricity per ton of refrigeration. This is also due to implementing different solutions and different optimization in the system. For example, most of it is through variable frequency driver retrofit programs and investment that we have done in the recent years, last 5 years. Also introducing digital tools, artificial intelligence to drive operations, from remote monitoring to remote operations of the plant, overlapping with these layers of optimization tools that will optimize the use of electricity and the use of the energy and the operations, of course. And all this will directly benefit the customers, as well as the grid. Another important thing to consider is that district cooling is generating a lot of data. If we consider the value that this data have especially because these are basically giving us information of the behavior of each single customer. So if we consider the benefit of having access to this information, to generate this information, and to put in place algorithm and big data analysis that can not only allow us to improve the demand management, but also our own operation and maintenance. So this is the big challenge, to have the data, to generate the data, but to use the data to optimize the entire system. On top of the improvement that we have seen through energy efficiency measures, we can consider that implementing these digital tools, artificial intelligence, can give at least 5% additional annual electrical efficiency improvement, which will, of course, generate more reduction in electricity and CO2 emissions. With the next slide, I think there is a problem in the animation, because there was an animation there. But here I want just to give you it's a brief introduction to the contribution of thermal energy storage in the district cooling system. This is one of the another benefit that district cooling can introduce that other technologies are not able to use with the same value for the entire system. And thermal energy storage coupled with district cooling is a big advantage in terms of not only energy efficiency, but also as security of supply. And when we also think about the storage problem that we have when we introduce intermittent energy in our grids, so we can understand that the importance of the storage today, and we know that also storage is expensive, but we often forget that one of the cheapest way to save to store electricity is basically through thermal storage, in this case chilled water. And if we couple this with the district cooling system, we will avoid the ramp up of the power production and having a favorable impact on the power grids, lowering the peak, shifting basically the peak electricity demand. And we have done a lot of demonstrations on peak shaving, and we really see that from 3 to 10% electrical efficiency improvement, also because of the use of the storage. Of course, this depends on the cooling profile. I'm talking specifically for I would say this specific region, but this is clearly one of the advantages that should be considered. When we look at innovation, we also have to have this R&D and innovation as a pillar for improving the sustainability of district cooling systems. And we at Tabreed, we strive for innovation, and we consider that innovation is crucial in the next years to reach the net zero carbon targets and to make our business more sustainable. So we have implemented many initiatives, I would say, that goes into this direction. And I would say either with new technologies or with existing technologies, but with different kind of integration in the system, innovative integration in the system. We have already experienced the nanotechnologies and the beneficial impact on efficiency, further improving the efficiency of the system, as well as the demand forecasting models. That this is more on the demand side management. And there are other initiatives that are ongoing on AI. All this has demonstrated having an additional benefit of 5% further reduction in electricity and CO2 emissions. One last consideration on the integration of renewable energy in the system. The coupling of district cooling, thermal energy storage, and renewable energies is a very successful way to making district cooling more sustainable and more efficient, with minimal energy, electrical energy required to drive pumps for geothermal, for example, or introducing solar energy in the system, will allow us to achieve a fully sustainable plant with many important benefits and savings in electricity and carbon footprint. So if we go to the last slide to wrap up, we have seen the benefits of district cooling in terms of reduction of carbon footprint. We have seen how operational efficiency is driven by innovation and new technologies introduced. We have seen the importance of thermal storage. We have seen how R&D is also essential, and the benefit of coupling and renewable energy in district cooling. So adopting efficient and sustainable cooling solution is crucial for achieving development and environmental targets, particularly in this region where the need for cooling is very high. So in this way, district cooling aligns very well with UAE energy strategy to get to zero carbon by 2050. And with this, I conclude my intervention. Thank you. Back to you.
Thank you, Antonio. Thank you very much. Very interesting to see the use of nanotechnology and AI has been kind of a common feature of the two DC providers. And now the last presentation for today is Mr. Jamal Yousef Al-Derbesti. He is a manager of district cooling service at Kahramaa, which is a state utility provider in Qatar.
Okay, thank you everyone. In the presentation here, we're just going to go through the district cooling sustainable solution earth regulator properly. That's the main thing and how we can go through it. And on the agenda, next one. Okay, the agenda for today's presentation, first we'll talk about Kahramaa district cooling department and the mandate of it. Then after that, then we'll talk about the district cooling market in Qatar and capacity saving, etc. in terms of numbers. Then we're going to move the technical regulation in place and the recycled water use. We'll go to the department map in the future. Next. Okay, this was just refreshment of the difference between the district cooling and the normal cooling systems and the feature in each one and how it can save. The district cooling is a unit can be distributed to different buildings instead of the conventional cooling is each one is a working individual. And that's why it makes district cooling is more economic and environmental friendly. To the next one. Qatar General Electricity Water Corporation, Kahramaa, of course, has established a district cooling service department in 2012. Okay, the mandate of the department is suggesting the generation, the district cooling, setting the rules, setting the district cooling standards and specification. We are monitoring the district cooling market to make sure the operation and the efficiency and effectively and compliance with the district cooling law and district cooling code. Enhancing the market competition in the district cooling sector. Mandate of the department, as you can see at the top, monitor all the work and the plant and operation and the quality. And the most important is promoting health, competitive district cooling market to provide social, economy, and environment benefits to the country. Here is just an example of our stakeholders, which is we divide them to three. The providers, which is we have two main providers in Qatar now, which is Qatar Pool and Marafiq, Lusail. Then we have the Derbesti. We have a lot, but the two main, or the two largest, is Qatar Foundation and Unshared. Okay, it's like a small city. It's by its own individual. Okay, then we have the governmental, like Jamal, Ministry of Commercial and Ministry of Municipality, Ministry of Environment, Public Health, and Kahramaa. It's just to show the capacity of district of cooling capacity in Qatar. In 2023, we have 5.5 million ton of refrigerant as all cooling system in Qatar. We have 1.1, almost 20% of it is by district cooling. Okay, and we have like 67 district cooling plant in Qatar for the time being. Here the graph is just showing from 2013 onwards up to 2022 how is the increase of the cooling in district cooling. We started with 355 ton refrigerant, and now we have almost more than 1 million. Here is a very simple, that's what we targeted in the future from 22 to 2030, how we can save in a different area like generation capacity, electricity, CO emission, potable water, and others. It's just, hopefully we're going to get it by 2030. This one is just a breakup of the numbers for each one, like for the potable water saving by using a TSE by 2022, we'll save like 14.4 by, hopefully, inshallah, if we got everything, we'll save around 33.2 by 2030, and the same thing for the CO emission by million ton. We are having 1.4 almost, and we're planning to 2.2 on the 2030. And the estimation of that, we're going to save approximately 1.2 billion Qatar riyal per year. In Qatar, we have a Qatar National Vision, okay, 2030, and that's the guide, the guide for us to go forward. We have 4 pillars. We have economy, human, social, and environmental development, and all of them. The more concerned we are concerning about the 3 which is related to ours, which is the economy and the environment and the social. The economy, promoting better energy efficiency practice related to electricity and water. Environment, how we can reduce the CO and other environment related. The same thing for social. Kahramaa published a district cooling code in 2016 in order to regulate technical aspects for district cooling. It contains 2 parts, standards and KPI, and we follow it with all the plants in Qatar. This is just an example of one KPI, which is energy efficiency, central plant defined here, which is less than 1 kilowatt per ton, and that depends, of course, on all the environment, like it's existing one, the source of water, and other that. And there are other KPIs in the website in Kahramaa. District cooling deployment, the process are automated and can access from Kahramaa website. 3 applications now available on the site, which is for emergency potable water, for the annual reports, and for the quarterly quality reports. All those processes, you find them in each plant has its own unique numbers and password to implement it. Then we do next. At the end of each year, cooling plant operations should submit performance of the cooling plant through a KM website, as we explained before. This data to be analyzed by our engineers, and then will be informed to their performance. Moreover, site inspection visit will be carried out in order to check, submit data, and site data are matching or not. Matching or not. Here we're talking about the district cooling potable water and consumption and how we can save it by using a TSE. Space cooling represented approximately 65% of the peak electricity demand. Qatar, which is make its most important contribution to energy consumption. Demand of cooling load meets water-cooled centralized chiller plants, which are the most efficiency option in terms of electricity consumption. However, utilizing water cool chilled process through the scarcity water resources, the region remain in Qatar. It's a desalination 100% of the seawater. And that Kahramaa District Cooling Service Department paving the way of Ministry Director and the prohibited potable water, the usage in the cooling system, and replace it with the TSE, recycled water, or seawater. Use of refresh for cooling purpose, which recycled water has economic and environmental benefit, while contributing to an increased water security of the country. This is just a diagram showing how we divert from potable water to TSE from 2014 to 2022. And that's the explanation of the Qatar District Cooling Sustainable Solution. But it has to such country it was if we are using a TSE. The roadmap to have more power and more regulation in the district cooling district area. We have the law, which is now finalized by our department and by our legal department, and now it's in the final stage with the Ministry of Council. This is our roadmap, and hopefully we'll reach it in 2030. Currently, we are on the regulation technical aspect only, but after the district cooling law, and so by 2025, Department will be fully fledged regulator, which control all the aspects of district cooling. By 2027, we will be regional, inshallah, district champion, and by 2030, will be worldwide. Thank you.
All right. Thank you very much for your presentation. And now we'll open up for like Q&A. And so I believe we are getting questions like on our Q&A. I'll just wait from Trupti to get back until we get questions. I just wanted to post 1 or 2 questions before we ask a Q&A from the public. This question is to all the panelists, like if they can open up their cameras, that would be very helpful so that people can see you. My first question particularly, there's a lot of discussion talked about how district cooling is being aligned to meet the increasing cooling demand, and also like the economic imperative to reduce natural gas consumption and to export the safe natural gas to the community. Now the question is with increasing heat island effects, with temperature increases, the overall increase in temperature in the region, and we're going to see intense heat waves, longer summers, and at the same time that we have this pressing need to reduce energy consumption and save greenhouse gas emissions. So what role that you have already explained, but I just wanted to kind of like as a discussion format, do you think like in the future is going to play by district cooling? This question is open to anyone like who wants to kind of like come forward to share this one. Aysha, Antonio, and Jamal. Yeah.
Sayeed, I can answer this question.
Please,
I guess actually ties in perfectly what we're doing in district cooling. And I think I probably touched upon it during my presentation. And as you mentioned, it is a very critical issue, the global greenhouse gas emissions and the rising temperatures. So as we know, the GCC is a hot, arid area, and the temperature is going to rise from now on, which means that the not district cooling, but cooling in general is going to be required more heavily than now. And this will be resulting in a lot of or more GHG emissions. This also causes warmer climate. And if district cooling is not being used or not being introduced, or governments do not take serious measures into dictating the use of district cooling in areas where district cooling makes sense, I think this issue is going to get worse. So the sheer existence of district cooling itself reduces the CO2 or carbon footprint in general in the atmosphere. So not only that, so using district cooling and continue to use more and more TSC instead of potable water, it means we're cutting on electricity and we're cutting on fuel consumption that is used to power these power grids. In addition to that, introduction of renewable energy, as this is now the talk of the hour, will really help reducing the temperatures and CO2 carbon footprint in general.
Thank you, Aysha. I just wanted to ask if Jamal and Antonio wanted to have their input if they wanted to.
And just an additional point from my side, I totally share the vision from our colleague from Qatar Cool. I would not repeat the same, but I would say all the efforts that can be done on the supply side are meaningful if we don't follow on the demand side. So there should be a combined effort. And this comes to education also, to educate people to save energy, to increase the temperature from 15 degrees in the room to maybe 20. It's still acceptable, and this has huge impact on the demand reduction. So this kind of behaviors has also an important impact to consider into the energy efficiency equation. And demand side management is crucial. So all the efforts that we can do on the district cooling side should be also followed by concrete actions on the maintenance of secondary side, correct design, and correct operations of the secondary system.
Okay, Mr. Jamal. Yes, go ahead.
Inshallah, Aysha, I think she explained most of the things. So we're not going to repeat what she said, and I agree with her. And as a government, we're already working in that thing about consumption of the AC in each building, and it is required. We're working very close with the Ministry of Environment. We can save how we can save electricity, which is going to consume less CO emission, and other than that, how we can transfer use the TEC as maximum as possible in the district cooling plant, so we can save all those things. So we are working on it as a government.
as the questions coming in, like I want to ask another question, particularly from a global perspective. And by 2050, almost like 2/3 of the world households like will have an air conditioning, and particularly China, India, Indonesia, and other developing countries like in the global south will be kind of dominating the share of air conditioning. And they are having the same kind of challenges, like in terms of reducing greenhouse gas emissions, like in terms of energy security. What these countries can learn from the Gulf countries, because they've been kind of ahead of it, what they can learn from DC providers in terms of experimenting and scaling up district cooling.
Okay, I think that is also something that of great importance. I've shared in my presentation. There are a lot of barriers, and I've listed a number of them with the suggested solutions that I think governments could actually benefit from. From our own experience, these barriers are the non-aggregated development decisions. As I mentioned, developers are not aware that when they make this decision as early as possible, it really helps. So they need to start talking. They need to start having this kind of dialogue and decide on sharing a district cooling network. Also, we've also talked about poor load planning. So you should aggregate your demand and then also plan your load. So if you plan your load, try to get it as accurate as possible. Don't overestimate it. Don't underestimate it. Also, governments could actually help in mitigating the risk of early investment. As I mentioned, that it requires a big capital cost required in front. Governments could actually jump in, maybe provide the network or the grid for district cooling, or help in providing these kind of investments. Cost misperceptions, I think the government should also be educating the public about the benefits of district cooling and what are these costs are about, in order to avoid the district cooling to appear expensive to the mass, especially in GCC, that the cost of electricity or utility is too low. And also designating an appropriate zone need to be allocated by government. So this zone and this zone should only be district cooling. I mean, in addition to regulating the tariffs and having a district cooling code, I guess all of these solutions could be implemented, and lessons should be learned, I guess, from the barriers and the obstacles that we in the Gulf have been suffering, to introduce a better experience in the countries that are looking into implementing district cooling in the future.
Thank you, Aysha. That's an excellent point. Antonio, Jamal, anyone like to kind of share their input on this particular question? Like, what can developing countries, the new emerging economies, can learn from the Gulf DC experiment?
Yes, this is Antonio here. If we consider district cooling in the region, it's relatively young development, because basically the first district cooling was introduced by Tabreed 25 years ago. So this is a clear example how a country or a region can take concrete actions towards sustainability goals if there is the support of all the stakeholders. We have the government and the policymakers, which are crucial in this to drive the sustainability with the good choices. And of course, the advocacy is also important. And I would say, adding up on all what has been said so far, education also is one of the key elements here. when we think about the future generations, the universities, etc., we have to explain also to our students what district cooling is, how the solution can be used for efficient cooling management, and encourage people to join district cooling companies.
All right, thank you. We have questions from people, so there are a bunch of questions. Is district cooling an economy of scale technology, i.e., the bigger the plant, the more economical the installation cost, and in return, the lower the tariff? The question is for anyone who wish to jump in. If possible, I could ask people who can able to turn on the cameras. It would be nice, instead of just me having you are the guys who are the stars for the show today, and I'm just the only person having a camera. So if you could able to turn on, please do so. Yes, is district cooling an economy of scale technology?
So if I can take this one, if I understand the question, is district cooling an economy of scale?
Yes. Yeah.
I mean, district cooling makes sense in high density areas where certain volumes of cooling are available. So it doesn't make sense to make district cooling in areas where the load is very low or where the density is very low. It doesn't make economical sense. Why? Because district cooling is an utility. And as all utilities, there are infrastructure costs. This infrastructure cost upfront makes a CapEx intensive, this solution. At the same time, goes with long-term contracts. So yes, there is an economy of scale. The bigger the system, more affordable and cost efficient is for everyone. But at the same time, you have to consider also, when you compare district cooling to other technologies, you have to consider the total cost, which many people are forgetting to compare Apple with Apple. If we compare district cooling, it's a 25 years investment. And when you install your own system, you don't have to consider the CapEx only for the first year and say, this is cheaper. Of course it is cheaper. But if you consider during the lifetime, you will see that the benefits are there. That's in a nutshell what I wanted to say.
All right. So to change your perspective looking at it, is it Aysha or Jamal?
I can take it, Sayeed, but I'm sorry I can't. I tried to switch on my camera, but as I said, I'm joining using two different devices, so I don't think it's working.
No problem.
It is the right economic solution, district cooling, when it is the right economic solution when it serves a sufficiently dense area, as my friend from Tabreed mentioned. So when taking network costs into account, the net advantages of district cooling becomes clearer in areas of sufficient cooling density. So the cost of the network also depends to an important degree on the load and the configuration of the cooling system. And I hope I've answered the question clearly.
Is district cooling suitable for low-rise developments, particularly housing schemes? This is just a follow-up question. You talked about high-rise, high-density building. But could it be done for low-rise buildings, like in a housing schemes, like gated communities?
Oh, yes, definitely. I don't know if I'm answering this with someone else. I would like to answer. Yes, definitely.
Yeah, go ahead, Antonio. Go ahead. Sorry.
I didn't want to cut because I have the audio in different time as the video, so it's not easy to follow. I was just going to say B2C and residential is part of the customers, because one of the advantage we are focusing on, because one of the advantage of district cooling is the diversity. Why district cooling is interesting in terms of also cost and economy of scale, because we benefit of the diversity of the customers, different profiles, and this requires less capacity to be installed, because residential demand is different from office demand. When people are at the office, they don't consume AC in the houses. So we can easily use this diversity as an advantage in terms of reducing the cost for the district cooling system and transfer this cost reduction to the customers.
Okay, right. There is a question to Kahramaa. There are two questions. One, like particularly for Kahramaa, and then one as a regional policy. Why not offer incentives or even subsidize district cooling customers as you would do with electricity? And the follow-up, another question is that what is the level of cooperation in the Gulf region in terms of policy making and DC development? And is there any difference in policies? I'm not sure if Jamal, if you can answer all the questions, but give it a go.
Come on, I could not get it. But the first one, the subsidiary is not by Kahramaa. Okay, the subsidiary is by the government. This is one. For Kahramaa, electricity, water, everyone is paid for it. So there are no subsidiary in Kahramaa. For district cooling, it's a completely different issue. It's as everyone knows, district cooling is a first-class cooling system. Let's make your life easier and all this thing, and that's why it's been chosen. Second question, what was?
The second question, what is the level of cooperation in the Gulf region in terms of policy making in DC development, and is there any difference in the policies?
There are slightly, different policy, but there are always a coordination between all the GCC regarding the regulation and all of those things, and not only through the district cooling, on consumption of the water strategy, electricity, those are communication.
Okay, there is a level of cooperation in that one. So this is a question like, how can Qatar Cool effectively manage the high operating costs associated with district cooling, whether through utilizing treated TSC or establishing a reverse osmosis plant?
I guess this connects nicely with what I was saying about the different financial models that developers usually use. So it depends. So you could use different financial model if you're leasing versus you're selling your units, whether you're having individual meters for each unit, or if you have 1 meter for the whole building, whether you're billing part of your rent agreement or your district cooling bill is separate. It is all different financial models, and the cost allocations are different. And unfortunately, what most of developers do is they try to pass this big capital investment, they try to pass it on to the end user. Which is something that is unfavorable and makes people avoid living in areas where district cooling is the choice. I guess with the government having a tighter grip on the district cooling and having a district cooling code in place, this will have a better impact on making district cooling the favorite choice of the market.
All right. Great. So we have one last question to Tabreed. Antonio, what is the utilization of the new Cairo capital city plant? If it's not confidential for you to share it.
I forgot to mention, Public is a public listed company, so you can find all the information available online. So I cannot disclose anything that is not published, but just for your information, the plant has been commissioned basically very recently. So when I say recently, is like a few weeks ago. So we are still in the beginning phase. It's 3,000 tons. It's a very small plant, but it's a concession of 15,000. So it's a first project that is very promising.
All right, great. So we have one final technical question, if any of you guys could want to respond. Is it possible for DC plant to combine with desalination plant in one serial system, considering water as the primary source?
In district cooling plant, the water is used either closed loop in the cooling side or as open loop in the evaporation side, in the condenser side. So we use the output of the desalination plant as an input for the district cooling plant. The most important is the district cooling plant should be the closest to the point of consumption. It doesn't make sense to make a district cooling plant in a very remote area where you have a long network until you reach the consumption, the demand side. So yes, power plant and desalination plants are always close to very remote areas. Yes, it is possible to use and couple the district cooling with desalination, etc. But we need to understand the business model of district cooling also to make this coupling economically viable.
Great. Okay, that's all the questions that we have. And just a final remark, thank you very much for everyone for your time and particularly for the insights that you've shared. And as Trupti said earlier, the presentation will be uploaded. The webinar will be uploaded on the website in a week's time or more. And also, I wanted to inform you that we're going to have a follow-up second series of webinar on district cooling. Particularly, we'll talk about with other providers and other regulators as well on their journey and what's been happening. And please keep an eye on UNEP website, and we will inform you, and we will send you the invitation to those who have registered. And we thank you very much for your time and input. And to all the participants, we appreciate your support. If you have any questions, please reach out to me or Trupti, and we will get back to you. Trupti, any final closing remarks from your end?
Yeah. Thank you to everyone who joined today and all the panelists for taking your valuable time to be part of this webinar. Also to you, Sayeed, thank you for moderating, and thank you to all the participants as well. And we hope to see you in the second session in September. So thank you, everyone, and have a nice day.